Hi, this is 1.6 geometric probability. We're going to use the area and length stuff to work on this in this lesson 1.6. This is the last lesson in Unit 1. After this lesson, there will be a review, covers 1.1 through 1.6, and we'll have a Unit 1 test as well. Okay, so now let's look at geometric probability. What is a probability? How do you find the probability of something? If every outcome in the sample space is equally likely, the theoretical probability of an event is, so probability is equal to, okay, the number of outcomes in the event divided by or over the number of outcomes in the sample space. So for example, if you throw a die, what's the probability of getting a even number? Okay, the probability of getting an even number. So that will be what are the outcomes, like what are the possible ways of getting even numbers? You can get a 2, you can get a 4, or you can get a 6. So that's 1, 2, 3. So there are three outcomes. A number of outcomes in the sample space. So that's the 3 even numbers you can get. And how many numbers you can, what's the possibility, what's the total outcomes if you throw that? You can get 1, 2, 3, 4, 5, or 6. So this is the total outcome in the sample space. There are 6 of them. So the probability of getting even number is 3 out of 6, which is 1/2. Okay, this is how you find the probability of something. We're going to use the probability in geometry today. If you look at this picture here, okay, this example here, a point is chosen randomly on segment PS. So PS, okay, is right here. And we're going to randomly choose a point between P and S. Find the probability of each event. The first one, okay, what's the probability the point that is chosen is on segment RS? Okay, I'm randomly pick a point on PS. What's the probability of the point lands on RS? So RS, how long is RS? RS is 5, right? What's the total probability? What's the total outcome in the sample space? So you can get in anywhere between P and S. So what's the length of PS? PS is 7 plus 13 plus 5. 7 plus 13 is 20. 20 plus 5 is 25. So the length of this segment PS is 25, but the probability of the point randomly chosen on RS is 5, right? The segment is 5, so 5 out of 25, which is 1/5. So this probability is 1/5. Second one, what's the probability the point is not on RQs? Not on RQs means either gonna be in PQ or RS. So what is PQ? PQ is 7. What is RS? RS is 5. So you can add these two. There are 12. That's the possible outcomes. That's the 12. And what's the sample space outcome? A total is still 25, right? So we have 12 out of 25. Next one. What's the probability the point is on PQR, RQR, either this or that? So what's the probability on PQ? On PQ, that will be 7 out of the total, which is 725. What's the probability if it's on QR? QR is 13. So 13 out of 25. So you can add them together, be this or that. So we have 20 out of 25. Simplify this fraction, divided by 5, you get 4 out of 5. So 4/5, that's the probability. Next one. Okay, use the figure below to find the probability. Then the point is on BD. So this is B, this is D. Okay, so BD, well, how long is BD? 3 plus 5 is 8. Okay, if you randomly pick a point on AD, and the length of AD is 4 plus 3 plus 5, and 7 plus 5 is 12. So 8 out of 12, that will be 2 out of 3, 2/3. Okay, so use the information below. What is the probability that the light will not be on red when you arrive? So the green light lasts for 25 seconds, yellow light is 5 seconds, the red light is 30 seconds. So if you randomly get there, if you gather at a random time, what's the probability the light will not be on red? Will not be on red means the light either going to be green or going to be on yellow. Okay, so how many seconds the green lights last? 25. How many seconds the yellow lights last? 5. So 25 plus 5 is 30. And how long does take the lights go around one cycle? So 25 plus 5 is 30. 30 plus 30 is 60. So it's have a 1/2. So you have a 50% chance when you gather the light is not on red. So either green or yellow. Okay, so this one. Okay, so there's a signal for the people who walk on the street here. Walk is 45 seconds. Don't walk is 70 seconds. When you actually go to the big cities, when you're in the intersection of two roads, the green sign for walking lasts for 45 seconds. The don't walk lasts for 70 seconds. Okay, so what is the probability the signal will show walk when you arrive? So the most of the time probably going to be don't walk, because don't walk sign lasts longer. But what's the probability of says walk when you get there? So walk is 45 seconds. 45 seconds out of what's the total number of seconds to go around one cycle? That's 45 plus 70. So you have 45 out of 115. So we're going to simplify this. Divide the number by 5. 45 divided by 5 is 9. 115 divided by 5 is 23. So the answer is 9 out of 23. That's the probability when you gather. It shows walk. Okay, so that means 14 out of 23. Out of 23, that will be the probability when you gather. It says do not walk. Okay, this is a walk, this is do not walk. If you add them together, it has to be a whole, has to be 100%. Okay, use the spinner to find the probability of each event. The point is not landing on green. This one, you gotta use the degrees, okay, how big each section. That yellow section is 140 degrees, this blue one is 52, this is 108, this is 60. If you add these together, the full circle end up to be 360 degrees, okay? So if you randomly spin this thing, what's the probability the pointer is not landing on green? Not landing on green, gonna be landing on these 3 sections, right? These 3 sections. So you do 60 plus 140 plus 52. Or you can just do 360 minus 108. You get the same answer, okay? You want to add them together, 60 plus 140, that's 200. 200 plus 50 is 252 degrees. If you do 360, subtract the 108, that's also 252 degrees. So these 3 sections are 252 degrees. Out of the total is 360. So this one, if you want to leave this one as a decimal, that's okay. Probability, you can either use fraction, simplified fraction, or you can use percent. That's both ways to represent probability. Maybe this one we're going to go with percent. It's going to do 252 divided by 360. We get 0.7, okay? 0.7 is what percent? That's 70%. So the 70% chance is not landing on green when you spin the spinner. So same thing here, use the spinner below to find the probability of the pointer landing on red or yellow. So we're only talking about either red or yellow. Red is 60 degrees, yellow is 140 degrees. Add them together, that's 200 degrees. 200 degrees out of total 360. Okay, and I'm gonna go ahead and divide. We get 0.555 repeating. I'm gonna go with 0.56, approximately 0.56, round up. That is 56% or 55.5555 repeating percent. Next one, these ones are gonna have something to do with the area. Find the probability that a point chosen randomly inside the rectangle is not inside the triangle, circle, or trapezoid. Okay, let's read this one again. Find the probability that a point chosen randomly inside the rectangle. So we have a point gonna be in a rectangle anywhere randomly. So what's the probability the point is not inside the triangle, circle, or trapezoid? Okay, it's not inside the circle, not inside the triangle, not inside this trapezoid. So what's the so what does that mean? It means if this is like you're throwing dart at this, okay, what's your chance of landing? Your dart is landing on the blues. Okay, not the purples, not the yellows, and not this light yellow either. So it has to land on the blues. So pretty much you're trying to see like what's the area of the blue, right? In terms of the total area of the rectangle. So find area of the blue, we have to use area of the rectangle, subtract the triangle, and subtract the trapezoid. What is left is the area of the blue, right? So that's what we're trying to do. So what's area of the triangle? So base times height divided by 2. So this is, the radius is 6. Okay, well, this one have something to do with the special right triangles. We actually haven't talked about. I'm just gonna kind of give it, this is 6. If this is 6, okay, this is 12. This is 6 square root over 3. So I'm just gonna go ahead and, you're not required to know this because we haven't learned it. So actually the base of each of the triangle is 10.4. So this is actually 10.4. We're just gonna use this number here, okay? This is 10.4. That's the base. The height, okay, the height is this is 12, this is 6, the height is 18. So the height is 18, the bottom is 10.4. Okay, so that's 6, no, actually 10.4 times 2 is 20.8. So the bottom is actually 20.8. Okay, just don't worry about the numbers here. You have to, for later the year, we'll get into how to find this. So this is 20.8. This is 18. Okay, so this is 18. So we're going to use these two numbers, find area of the triangle. They're going to find area of the trapezoid. They will subtract both from the rectangle. So maybe we'll do the rectangle first. The rectangle area is length times width. So 45 times 20, which is 900 meters squared. For the triangle, okay, triangle area is base times height divided by 2. So base is 20.8, height is 18, then divided by 2. 18 divided by 2 is 9, so we're just doing 20.8 times by 9. The answer is 187.2 meters squared. And this and the trapezoid. Okay, trapezoid is, okay, kind of relates to the triangle. Triangle is base times height divided by 2. Trapezoid is base 1 plus base 2 times height divided by 2. The base 1 is 12 plus 3. That's 15 times the height. The height is 10 and divided by 2. So 15 times 10 is 150. 150 divided by 2 is 75. Or you can do 10 divided by 2 is 5. 5 times 15 is 75. So these are these two things. So the area of the blue, you're going to use the rectangle one, subtract the triangle, and then subtract the trapezoid. So 900 minus 187.2 minus 75, we get 637.8 meters squared. So this is the area of the blue section. So what's the probability if you throw a dart into the rectangle? It's not in the shapes, but it's in the blue section. The blue section has a total area of 637.8 Then you're gonna divide it by the total area of the rectangle, right? The rectangle total, you can do, your point can land anywhere in the rectangle. Rectangle is 900, which is just gonna make sure it's not inside the triangle, circle, or the other trapezoid. Okay, 0.708. Let's go with 71. That's 71%. Okay, approximately 71% chance you're gonna throw this dart that's not inside the shapes. It's gonna be on the blue section. Okay, this one, just don't worry about how I found these numbers. Just make sure you know how to find the area of a triangle with the numbers are given. The focus on this lesson is using the area and the length of the stuff to find the probability of something happens.